Mic check. Okay. We got a small crowd tonight. Probably everyone's a little burned out from the project, but I assume maybe more will show up. Good evening. So I finished grading all the projects. So if you haven't seen, you've gotten some feedback and scoring from me on the first project. There's a lot of really good ones. And hopefully, I mean, the idea, of course, is for you to demonstrate that you have those basic skills that are reflected in the requirements of the project. But if you struggle with some aspect of the project, then that's an opportunity for you to identify that thing or those things that you struggled with and work on that. For many of you, this is your major, so it's at some point you're going to want to start making software on your own, off to the side of all of our projects. If you're already doing that, then that's great. That's what you ought to be doing. It's a habit that you have to get into. So I don't have my code to show you, but I've spent, since I last saw you, I've been working on this ray tracer algorithm, and I have written, I don't know, 2,000 lines of code and over about 12 hours of work since I last saw you, and that's just me practicing. I'm going to go back and actually implement that same ray tracer in a different language after I do one in C++. But just to let you know that I also do that. I'm not naturally talented. It's a craft. I have to practice it. So the projects are a good opportunity to identify what you should be practicing and go back and practice those things. Okay, so I didn't say any nice welcomes. I hope your weather's good. My weather here is getting just a little bit better, so it's very hot here for long parts of the year where I am, and it's finally starting to get cool in the evening. So that's the best plus I have to offer. The ray tracer program, by the way, the math is difficult, but it's pretty satisfying, I would have to say. To get little pieces of it to work. Okay, so let's look at where we're at. So we just finished a project, and I know for some of you that may have meant that you had a miserable Sunday. It's one of those things that some people will get good at, and some people will always have the habit of doing things at the last minute. All I can do is just beg you to try to do things over time. Technically, you had 6 weeks to finish the first project. I wrote mine in 40 minutes. The one that I put the screenshots of, I wrote it that morning just because I felt like it, and wrote it in 40 minutes. So you had 6 weeks. If you didn't have 6 weeks, that's because you chose that. But I'm just saying, if you felt stressed because it all came piling up on you on the last day, try something different this time. Get started early. Get on Piazza. You have got really terrific classmates out there who are answering questions on Piazza. So you're surrounded by people who want to help you. So if you get started early, you will encounter the challenges early, and you can then ask questions about it and get answers to those challenges early. So anyway, please consider that at least. I know a lot of people waited until Sunday, if not Sunday night, and then discovered that you couldn't get rid of that last bug, or it was actually more work than you thought it would be. One of these days you'll go back and you'll find that to be an easy project. But for now, don't assume they're going to be easy. Assume that the 6 weeks might be needed. So I just sent a message to everybody. Oh yeah, good point, Baby Doll. So Baby Doll is reminding everybody that the team project also, ask on Piazza. Everybody has a team with a small number of members in it, but that doesn't mean that everybody can't help everybody. There's a couple of spots in there where the algorithms are challenging. It's not a lot of code, but there's a couple of places where you really have to think about what you're doing. So Baby Doll's totally right. Piazza is a great place to go help each other. And I'll just remind you that being the person who answers a question and helps someone else, that feels really good. So if you ask a question, you are giving someone else an opportunity to feel good that they helped you. So think about that, please. Okay, so I did send a Canvas in, so you'll get a message in Canvas inbox about the team projects. It's here on the home page. It's not long, but it would be a lot less stressful if you just sort of get in there and get to work on it and knock it out, and then move on to other things, because the second individual project is now spinning up as well. Okay, so that's that. We are in week 7. So you don't have to worry about individual project 1 anymore. That's done and gone. Individual project 2, sooner than later, you need to read that as well, to get a sense of what is required in it. What did I say? Oh, week 7. Week 7. So let's just walk through all the materials for the week, and then we'll oh yeah, I'll do it later. Let's look through all this first, and then I'll show you a randomly selected, what I thought was a really clean, crisp project, so that if you struggled with it, you can see at least the implementation, the executable part of someone's project who was successful with it. Okay, but we'll do that after we just step through what's the content. So this week is, when you see this std : in C++, that means something from the standard libraries, which means that if you have a C++, you're going to have access to these things. So we're going to use the C++ standard library string and the C++ standard library vector. I'll just give you a heads up right from the start. The reason why we're doing both of these this week is because in many ways they're exactly the same, which I'll talk about here in just a few moments. But they share a lot of the same properties and a lot of the same behaviors, so learning them at the same time is actually a relatively easy thing to do. Readings, so that's chapter 9. So one thing you'll notice starting this week is a supplemental videos section. What these are is the videos that I made, the broadcast that I did last spring when we were sent home from school, and I had to do things on Twitch last spring. So for the rest of the semester in this class, there will be supplemental videos that I shot last spring, and I thought, why waste them? They're already out there. You'll notice sort of the old me with a little bit different hair and facial hair. They're captioned at this point, so the captioning service has caught up and captioned them all. The one thing I'll tell you about the supplemental videos is that there's a lot of lab spoilers in them. So if you don't like me giving spoilers on labs, meaning I show you how to do the solution to the lab, try your own solution first and before you view the supplemental videos. But we're all grown-ups, so use the supplemental videos as you will. I'm just sort of heads up. They have a lot of lab spoilers in them because we were scrambling last spring to finish this semester and feel somewhat successful. So there's a lot more answers in those videos than I would normally hand out during a lecture in normal times. Some weeks there will be 2 supplemental videos, and other weeks just 1. But those are already there. If you've been looking around, you probably saw that those are also already listed on the videos page as well. So you can find those supplemental videos in all the usual places. They're on Twitch, they're on YouTube, and they're also captioned by our captioning service. Okay, so the lab assignment I'll come back to, but it is a lab assignment that has you using strings and vectors. What's the discussion? Oh, to describe in your own words what a vector is. So I think one thing you'll discover as you grow more confident in your knowledge is that you will describe things in programming and the way things work in ways that other people may not be describing them. And the point here is to let you know that that's okay. However you learn to explain to yourself how a thing works, if that explanation makes it so you can use that thing to solve problems, then your explanation is correct. So it's interesting for me to hear people describe how they think things work, because I learn a lot about how different people internalize this information. So it's not a test about who's going to get the correct answer on the Piazza discussion about what is a vector. It's really just an opportunity to let you use your own words and describe how you think this thing works. But if you're super, super shy, then go out and hunt down some kind of textbook definition of a vector. That's okay too. But there will come a day when you will feel confident enough to say, here's how I explain how vectors work, and you won't be shy about it because you know that you know how they work. And then, as usual, the reminders. So lab and discussion as always. The team project, please consider being that person in your group to reach out and get the conversation going. That's 2 weeks away now. It's not a whole lot of work, but you don't want 3 or 4 of you scrambling on a Sunday night to figure out how to finish this thing. Just get in there as a group and knock the pieces out. And then sooner than later, the second individual project. You don't have 6 weeks for that this time, you have about a month, so you also need to sort of mix that into your workflow. Okay, so before we do new stuff, I just thought I'd go show you an implementation. So I don't think that there's any identifying information about the person here. If you did a really good project and this one isn't yours, I apologize for that. I'd like to show everybody's who had a really cool project, but I had to just sort of pick one at random to show it. So if you didn't get the result you were hoping for on the first project, I'm just going to run this one and sort of talk a little bit about what's good about it, just from the executable side of things. Okay, so this one does how I attack projects, which is just do the requirements. So here's the menu requirement. It has the items, it has their prices, it has the amount in stock, and it has an option to check out, which is explicitly required in the instructions. Right there on the menu, just as the instructions say. So that's good. And let me show you then how I exercise these programs. So I notice that Dr. Pepper is low in stock. That's a good touch, by the way. That is very thoughtful of the teacher and the TA who have to evaluate this code, because if we want to see if I can get this to be sold out and see what the simulation does when this sells out, this programmer has made this very easy for me to buy one Dr. Pepper and boom, it's already sold out. So that's a very, very nice touch. That makes it very easy to test. And I would bet you that this programmer used that for their own testing as well. So I'm going to buy a Dr. Pepper. Hopefully, let me make sure you can see the whole screen here. Okay, you can. So down here at the bottom of the screen, it's inviting me. Now, I didn't do this to anybody's programs. It's kind of inviting me to see what happens if I type in a 2. So I'm gonna type in a 2. Aha, perfect. It has an output, so it doesn't make me go through a whole rigmarole again. It just immediately says that's more than we have. So I'm going to go back and I'm going to buy just the one that there is. Bought. Press enter to continue. So now it says sold out. So I'm curious to know what happens if I try to buy one when it's sold out. Okay, it just doesn't let me do anything. It doesn't make me enter a number saying, well, it's sold out, but you still have to say you want 0 of them or anything like that. So it's very user friendly, and that's great when someone like me has to sit there for 10 to 12 hours over 2 days grading these things. It's super, super helpful to do that. So now I'm just going to buy a few. I'm going to buy a water. I'll buy 2 of those. I'll buy one of the onigiri. All right, so I bought some stuff. I'm noticing that the stock market, the stock values are going down. This repeating the menu is kind of crucial if you want to demonstrate that your stock decrementing is working, because if you don't redisplay the menu after every selection or after some selections, then it's very difficult for anybody testing your code to know that the stock values are counting down. So I'm ready to check out. Okay, and this one is doing the same technique that I showed in the screenshots, and that's great. Other people did different ways, but this is going to work out. So this one's also inviting me just to see what happens if I only pay like 50 cents or 1 cent. Okay, going good so far. And then what I typically will do, let's get myself 450. Let's go up to 450. What I'll typically do is sort of get myself right up underneath the amount that's owed, just to see when you get near that breaking point what happens. And then I'm going to pay 2 cents, which in theory means I should get a penny back, which I did. And here's a nice, I didn't call it a receipt in the requirements, but it's one of the last requirement was that you show how much of the items were bought and how much the total of the purchases was. This programmer put extra detail in the receipt display. It wasn't required, but it's a nice touch to have counted. And the whole reason to do that is to prove that you can track data and do calculations like 3 of this at 99 cents equals that. You can do those calculations. Also, by the way, all the currency values are printed with the magic formula, which we used over and over and over again. And I think most people incorporated it into their projects, but if you didn't, the reason why we practiced it over and over and over again was in part because I was hoping you'd use it in the project. Okay, so that is what I would call a very crisp project. It is fairly robust, meaning it didn't let me buy stuff that was sold out. It didn't go negative. It made me pay adequate amount of money. It gave me change when I paid too much. It did all the stuff that it should have done. It had a dynamic menu that constantly refreshed to show me the stock counters going down. And then it had a nice receipt with some extra detail. So that's a really, really good one. And a bunch of you did programs that are like this, and that's great. If you did extra stuff on top of that, that's fine. There's no harm in it, but there's also no harm in just hit the technical requirements and make them super crisp and bug-free, and that's a good piece of software. Yeah, that one is quite well done. So anyway, that wasn't the only one. I picked one at random of the ones that I thought was crisp like that, and easy for me to use as a user. I didn't have to sort of sit there and figure out what am I supposed to do next. It's pretty obvious. Okay, so gotta watch the time. I don't want to spend too much time on that. So for those of you who didn't get the result that you wanted, that was an example of one that's sort of, really crisp is what I would call it. It satisfies all the requirements, and it does it bug-free and easy to use, and the display is easy to read, and it presents all the information that's being tracked and computed inside the program in a way that's easy for someone who's trying to evaluate the program. It's easy for someone like that to read it, in this case me. Okay, so good job. And good job to a lot of you. A lot of you did nice, clean, crisp programs like that. Okay, so I'm going to make a REPL and talk about a couple of things that I saw in the project. Are you going to let me make one? Okay, here it is. Oh, except for it's called Crushing Something Stupid. Let me change the name. Lab 7. Okay, so before I go into this week's stuff, the string and the vector stuff, I wanted to just talk about a couple of things that I saw often enough that I thought I should bring them to your attention. So one of them is pretty subtle, but let me show you the problem. So let me just make a struct here. I'll call it item. Actually, this brings up another one. while I'm at it. So the names of things matter. Choosing names for your structs and your variables and your functions carefully is important because it's documenting your code. So this struct item, if some other programmer is reading my code, one would hope that they would get the idea that I am about to create a C++ representation of an item for something. A pretty common issue that I see is people, they'll think to themselves, well, I need 5 items in my program, so I will call it items. But calling a struct items means that what you're saying is, I'm about to create something that represents multiple things at once. It doesn't. In almost every case, your structs and your classes are going to be in the singular. You're going to be creating them to represent one thing, and then you might create multiple instances of it. So let me give myself a string in here. And a quantity, I'm going to need an include for that string. All right, so that was one thing, is choose the names purposefully. They document stuff. So I called this name, meaning that's the name of the item, as opposed to, you know, Sniggle Fritz, which is what my mother used to call her dog. Another program is going to look at that and say, what is that about? What is that supposed to mean? So you choose names because they document the purpose of your code. Another program is to say, oh, you're modeling an item, and items have names, and items have quantities. Makes sense. Now, if you need multiple items, well, the model doesn't change. You create a blueprint for one thing. If you go to a home builder's offices, you won't find a blueprint. You won't pull out a blueprint and it has pictures of 1,000 houses. It's a blueprint of one house. And then they use it to build multiple houses. Same idea. So do flowers tonight. That's what I feel like doing. 3 roses. I'm going to run out of flower names pretty quick here. Daisies. That's easy to spell. So now I have 2 items, but the struct is in the singular because the struct is really a blueprint for a single item. And then I can make multiple instances of it using that blueprint. Okay, so that's the singular plural thing. So here's another thing that was fairly common. So let's say that I have, let's just do a counter. So let's just say I'm going to do a while count greater than 0 thing. So I'm just going to do something 5 times just for the heck of it. And notice where I am in this while loop. So I'm going to print out i1.name and i1.quantity, and then I'm going to do it for i2. By the way, the moment that you have 2 lines of code that look exactly the same except for one little tweak is the moment when you should start thinking about creating a function for this. There's no need to have duplicate code. If you see 2 lines that almost duplicate each other, think maybe I should have a function here. Now I'm not doing that just to save time and screen space, but I know I feel bad not making a function for that because it's just bad. It's just bad programming to have a whole bunch of duplicated code. Copying and pasting lines of code can lead to lots of mistakes. Because if I go back and I make a change to the first copy and pasted one and I forget to make changes to the second copy and pasted one, all of a sudden they're different and I may have introduced a bug. Alright, but i1.quantity, so I'll decrement the quantities. and then I'll print them again. And another sort of just tip to make your life a little easier, when you're doing testing like this, don't forget that you can do outputs wherever you want to in most cases. So I want to be able to know, I'm going to put an extra blank line here, I want to know when I'm switching from one pass of the loop to the next pass of the loop. I'm going to put 2 there as well. So between passes of the loop, I'm going to put this little line so that it's easier for me to see, okay, that was the first pass, that was the second pass, and so on. I forgot to decrement the counter. So I'm going to count down until I hit 0. And each time I'm going to be printing the quantity and then decrementing the quantity and print it again. So this is a fairly common mistake, and it caused people to have bad decrementing stock counters. So let's run it and see what happens. Okay, so see how I just used these to make a little separator, because that was so easy to do. So here's the first pass. 3 roses and 5 daisies, and then I decrement them, they become 2 and 4. But they're now back to 3 and 5 and 2 and 4. So the counters aren't resetting. Some of you are going to know this answer. There's something wrong with my loop, kind of. There's something inside of my loop that shouldn't be there, and it's causing the counters to reset. Does anyone know what that is? It can be fair. There we go. So Baby Doll's got it. These 2 items, I've created them inside of the while loop. So the thing you got to remember is you use these blocks of code with the curly braces. Those are called scopes. S-C-O-P-E, scope. If you have declared a variable inside of a scope like this, that variable is created in that scope and only lives in that scope. Now in the case of a while loop, what happens is every time this while loop repeats, it recreates these 2 items over and over and over and over and over again. So if I don't want those counters resetting, I have to take the 2 items and declare them outside of that scope so that the creation part of them is not repeated by the loop. So I create them first, and now the loop is going to make alterations to them. I'm going to make these numbers bigger so the loop doesn't do silly stuff with them. So you need to be mindful of where you're actually declaring or creating things, because that can affect their lifetime. So now the items come to be before the while loop, and then they are altered by the while loop, and it turns out that they will still be available after the while loop. So the scope of these 2 items is actually this outer block of main, which also happens to cover the while block. But if there were variables inside of the while block, they are created and recreated inside of the while block. So I'll run that and we'll see that the counters go down. So there's the first one, they go down, and then the second pass through the loop, they retain the values from the last pass because they're not being created again, and they go down, they go down, they go down, and then finally after 5 passes it stops. So that was common enough where I thought I should just share that with everybody to be mindful of that. Okay, the last thing about the projects, and then we'll do lab stuff. Let me make myself a notes file and move this stuff to the side. I don't care about item, I'll just leave item, it doesn't matter. This stuff I want out of the way. Okay, so here's another thing that I saw. And this is just practicing your programming. So I'm simulating a little bit here, but let's say that we have a menu and the user is going to make a choice, and that their choice was 3s, right? So there's, pretend there's a menu here, and then pretend the user chose option 3. All right, so I'm going to do it the wrong way. Technically, it's not wrong because it would work, but there's a couple of problems with it potentially. So it doesn't really matter what the code does. So this is where this can be a problem. Okay, so this was common enough that I thought I should point it out. The thing to start with is the idea that all of this that I've highlighted is meant to respond to that choice. If the choice was 1, do one thing. If the choice was 2, do something different. If the choice was 3, do something else. Or if the choice was none of those, then do the else part. There's a problem with this, and it's hard to describe. So if you might be able, and I'll go ahead and give you a second to see if you can come up with the words to explain it. But this is meant to be a single decision tree. One tree with one possible outcome based on one choice. So the way I've written it, there's something wrong about this if I intended for it to be a single decision tree and look like a single decision tree. Can anyone see what it is? Now, while you're thinking, I'm going to put some outputs in here. Yes, so Glazer got it. I should have been using else ifs, and let me just show you how this can lead to problems. This is not the only kind of problem this can lead to, but here is one kind of problem that it can lead to. So if you have bad habits about writing your decision trees, this is an example of where that can come to bite you. So I'm going to run this. In theory, it should say, let me choose choice 1, just for the heck of it, and run it, and let's see what happens. Choice 1, and invalid choice. Now that doesn't make any sense because choice 1 is totally valid, but it's saying invalid choice. So this is one of those little logic bombs that you can introduce into your code if you don't know how to make decision trees. So Glazer got it. The truth about this is that I have one if statement followed by a second separate if statement followed by a third if statement that also has an else branch on it. So this is just a bad logic tree, a bad decision tree. If you see yourself stacking ifs, there are some algorithms that require that you stack ifs like this. But if you find yourself stacking ifs on top of each other like this, there's a good chance that you have a bad decision tree. So what Glazer said is correct. What this should be is one tree, and the way you make it into one tree is you connect it all together with else ifs. So now this is one decision tree, and it can only have one outcome. So choice 1, that's correct. So be on the lookout for that. I saw that enough times that I thought I should call your attention to it. The other reason you don't want to do this is because if you're working with other programmers someday, they're going to see this, and one, they're going to think you don't know what you're doing. but also they're going to be irritated because why didn't you make a decision tree? Why did you write it this way? Unless there's some good reason why you did it. It's just confusing looking. Like, okay, I've got 3 separate if statements for some reason. There should be a reason. And when they discover that there is no reason, they're going to wonder if you were trolling them. So, does this redo? No. So anyway, if you intend for that choice to lead to one possible outcome, then make one tree out of it with else-ifs. Don't stack ifs. Okay, so that's that. That's the project stuff. Just setting these off to the side so I can have them later if I want them. I do not need item. Okay, so we're now getting on to what we're doing in the lab today, which is starting to use collections. And the collections we're going to use are string and vector. And they are both collections. String is a special or a specialized type of collection, and vector, in a lot of languages we'd call this a generic collection. In C++ they call it a template collection or a template class. So string and vector, they're very, very similar except for in terms of the way they operate, strings happen to be specialized. So to use these standard library collections, you have to have includes for them. And let's make a couple. So I made a string S. One thing to note here, and this is different from an integer, just so you know, you notice that the int is blue and the string is not. The reason why the int is blue in here and the string is not is because the int is actually built into the language and the string is not. The string is actually added on as a library, which is why we have to have this include. So the fact that this is added on from a library with an include and the fact that it doesn't highlight itself in most text editors is a clue that something is slightly different about it. And there's several things that are different about it. Integers, the 2 main things to remember about something like an integer is that all an integer is a whole number. That's all it is, that's all it ever can be. It doesn't have any functions attached to it, it has no special behaviors, it's just an integer. That's one thing. We call that a primitive type. It's a primitive integer because all it does is represent a piece of data. The other thing to remember about these primitives is that they're not guaranteed to be initialized. Meaning right now, I don't know what the value of x is. It could be 0, but it could be something else entirely in C++. So with primitives, you need to get in the habit of initializing them. You can initialize them with parentheses style, with what we call constructor style, or you can initialize them with assignment style. But the primitives, the ones that light up in blue, should be initialized in C++. Because they're not guaranteed to be any value otherwise. It's unknown. The other thing, by the way, if you do something like this, some people think this is bad programming style. It doesn't bother me a whole lot, but right now I have 3 uninitialized integers. If I initialize the z, only the z is being initialized. Y and x still are nothing. So you have to actually initialize all of them. One reason why I think some people think it's bad style to stack them on a line like that is because it's easy to forget to initialize them. You can also do this. They need to be initialized. Or they're at no predictable value. So remember that about primitives. Okay, strings. Strings are different, and it turns out that strings are initialized. They have an initial state. They actually have a constructor. So if you make a default string with no contents, the string default constructor actually loads up the string. It creates the string with nothing in it, and you can see that. So I'm going to print out the string. It can be helpful, by the way, to put little notes to yourself. Here comes the string. It also, by the way, has a size. Why are those different? Has a size. So I can grab a string and I can figure out its size in terms of the number of characters it has in it. I'm going to line those up because I think it would look nicer that way for me. So they also have a size, but let's run it and just see what we get. Okay, so the string by default, its size is 0, which means it contains 0 characters, and it prints nothing. Here's another just sort of tip. If I want to be sure, absolutely sure, that that string is actually nothing, I can confirm that by putting something around it. Let's say like a vertical bar just for fun. So with no spaces on either side of it, I put a vertical bar around that string, and in theory, if it's empty, they should be mushed together. That's correct, Glazer. So Glazer asked, is that then what we would call an empty string? And it is, yes. So an empty string will print as nothing, which I'm going to prove with my vertical bars, and an empty string will show a size of 0 characters in it. So there's the vertical bars mushed together because there's actually nothing in there. It's an empty string. So empty string is a valid state. It's a known state. That's different from integers. If you don't initialize an integer, the value of it is completely unknown. Whereas if you don't initialize a string, it initializes itself to 0-sized nothing, which is fine because you can program with that. Now you can also initialize strings with contents to start. So I'm going to use an overloaded constructor here on the string, so that its initial contents will say hello and its size should be 5. And again, the vertical bars are there to just kind of prove that there's no extra spaces going on or anything. It's just the characters hello and a size of 5. So that's good. All right, a couple of other sort of basic things about it. It also has a length function, which is exactly the same as size. It can be a little off-putting that it has 2 functions that do exactly the same thing, but sometimes people who create libraries do that to be user-friendly, so that other programmers who might be used to length use that. I only ever use size myself, but I just want to show you that second one using the length shows 5 because it's exactly the same. So if you come across a string grabbing its length, that's the size. If you prefer length, use that, but I use size myself. And there's a reason for that, because size is universal in the standard library collections. Okay, some other things that strings can do. You can grab individual characters. So you can get, this is just like 0 indexing. So strings are specialized collections. They are like arrays of characters. So they operate just like arrays. If you want to get the character at position 0, you can do that. That should be an H. So there's the H. There's also an alternate syntax for this. it actually supports the array style subscripting, we call it. Same thing. So it's an alternative. Same character. I happen to prefer the .at for some reason. I didn't used to, but now I always type the .at. So that's the string at position 0 is a character, because strings are collections of characters. So getting one of a collection of characters is a character. So we can do that. We can also do grab substrings. We won't need this anytime soon, but just so you know, you can grab substrings. You can tell it where to start. So say start at character 1 and go for 3 characters. So we're grabbing a subset of the string, starting at position 1 and going for 3 characters. So there's the substring. Position 1 is the E, and then if we grab 3 characters starting at position 1, we get ELL. So that's something else that strings can do, even though we don't need it tonight. I'm just sort of pointing out to you that strings can do lots of different things. If you go to c++.com, you'll find that they do lots of different things. All right, what else do we want to do? Let's loop it. So hopefully you remember from your experience with arrays in some language, or whatever they called arrays in the language that you have used before. One of the things that we often do with arrays is we write for loops to process them one element at a time. So there's actually a whole bunch of ways to do this. I'm going to show you 3 different ways to do this for a C++ string. And I'm going to be mixing in a little bit of more of my style of doing things as I go. So hopefully you don't find this off-putting. But I'm going to start using size t. When you see this, just know that that is a non-negative integer. It's very common, especially when we're doing things with collections, to use size t. So that's a thing in C++. It's not highlighting, but it'll work. That means a non-zero integer, and it's very good for things like indexing arrays or indexing collections, which strings are. So you're going to recognize this otherwise. If I start at the 0 position and I keep going until I've run down to the end of the string, 1 character at a time. So this is a traditional int I equals 0, I is less than something I plus plus. But you'll see a lot of people use size t, and all that really means is I know this is going to be 0 or greater. If you're in the assembly class, this is an unsigned integer. Okay, so this is one way to process the individual elements of a collection, like a string, which is a collection of characters. And I'm going to use couts here just to show you. Character at position. Use the I to print out the position, and then I'll use a semicolon, and then I will do s.at I. So I'm going to use the at function with I as the position marker, the index, if you will. So what this should say is character at position 0, 1, 2, 3, 4, and it'll stop at the end. So here's the position 0 is the H, 1 is the E, 2 is the L, 3 is the L, 4 is the O. So this is one way to cycle through a string. I'll show you a trick while we're at it here. So one thing that you can do, you can actually overwrite the characters if you want to. So in this case, I'm going to uppercase the character. Hint, hint, this is on the lab. So I'm going to print out some information about the character, and then I'm going to use this built-in function to upper. And I'm going to convert the character at position I to uppercase and then overwrite the character at that same position with its now uppercase form. So when we get out of here, it should be all uppercase letters. So I've used this loop to convert the entire string to uppercase. So there's the all uppercase HELLO. So that's one loop. You don't necessarily have to print out stuff. I just wanted to show you that you can. But the work that this loop actually does is it takes each character in turn, converts it to its uppercase form, and then overwrites the original character with the now uppercased form of itself. So when I get out of the loop, I now have an all uppercase string. So that's one way to do string looping. Second way to do it. So this is called I think they call them like range-based loops. If you've had Go, you've seen these kinds of loops before. So I love the range-based loop. In C++, the newer C++s all have it since C++ 11. So this is a second way that you can process all of the characters in a string. So if you go look on Stack Overflow, you're going to see people using the keyword auto here. But I'm not going to do that, and that's because I think you'll understand it better if I don't do it that way. So the way the range-based loop works is it grabs one element from a collection. So on the left-hand side, you say what kinds of elements that you expect to get from which collection. So our collection is S, the string. I'll go ahead and put the curlies on it. The elements of that string are characters. So I'm going to get characters out of there. You also have to label the characters so that you can refer to them inside of the loop. I'll call it C. So for each character that I'm going to call C, taken one at a time from the string S, the first thing I'm going to do is just print them. Now with the range-based loop, I no longer have the index numbers. This is an automatic loop that automatically pulls one character at a time until there's no more collection to process. So for each character C that I pull from the string S, I'm going to print out that character. So what you'll see is at the bottom all of the characters printed one at a time. I don't have the position, the I, to print because the range-based loop doesn't give you that. So I'm just printing out the characters. But you can do things, and I'll probably update the string to show this. You can do things like this. So I can do tests on the individual characters. This is digit. I'll show you where I find these things. Is also built in. So I can take that character, one character at a time from that string, and I can test it to see if it's different kinds of characters. So I can see if it's a digit. I can see if it is, I think I can say is if it's alphabetic. I can see if it is alphanumeric, which would be numbers or letters. I can see if it's, notice how, by the way, I'm using a decision tree. I can see if it's a space type character, which would be mostly spaces and tabs. And I can see if it's punctuation. So there's a whole bunch of built-in little tests that you can run on individual characters from a string. So the whole idea is that you set up a loop that grabs one character at a time, and then you subject those characters to these little checks to see what kind of characters they are. Now this one's a little bit weird, by the way, because digits and alphabetic characters will mean that alnum never fires off. So in this case, I'm actually going to do that as a separate decision. Because digits and alphabetic characters would also satisfy this test, I'm going to do that one separately. Now that does mean that alphabetic characters are going to trigger two parts of my testing. The other thing we want to do here, are we doing okay on time? Wow, I've been burned up a lot of time. The other thing we want to do here is make the string more interesting to look at. So I'm going to go up here to my original hello, and I'm going to put a whole bunch of garbage in here. So 1H, put some stuff, put a space in there, a capital letter, a comma, a parenthesis, another space, a couple of digits, an exclamation point, just so that when we get down to our little loop that tells us what kind of thing that is, it's interesting to look at. What you're going to see, by the way, is this my little loop that to uppercases things. Watch what happens. I've only got, well, that's an E and an L, but the E is already uppercased. So we'll see what the to uppering does to a string that has all kinds of weird stuff in it. Now the reason I wrote it all weird like this is because I want to see how my little character tests work. All these functions, to upper, there's also a to lower, is alnum, is digit, is alpha, is space, is punct, those are all built in. Those are all standard library functions. Okay, so here they are. Here's the string after it's been uppercased, by the way. So notice that it actually only affected the actual characters that can be uppercased, and the one that was already uppercased was left unchanged. So that's a fairly safe operation to do. Now we get to the other loop. So 1 passes the alphanumeric test and it passes the digit test. H, alphanumeric and alphabetic. The semicolon is punctuation, the pound sign is punctuation. Then I put a space character, which was identified. The E is alphanumeric and alphabetic. The L, there's a punctuation, there was another space, there's an alphanumeric digit, and finally a punctuation. You're going to need those on the lab because one of your jobs is to use counters. So one thing I'll remind you of, if you're going to do counters in here, do not put your counter inside the loop. If you declare this counter inside the loop, it's going to be recreated every time the loop goes through, which is completely useless. So if you want this loop to actually count punctuation for you, you have to declare that outside of the loop. And then when you encounter punctuation, you can say, okay, I got some punctuation there. And then after the loop, you can say, found punctuation characters. So it found 5. I could go confirm that. 1, 2, 3, 4, 5. That's correct. So hint, hint for the lab this week about that. I'm going to show you one other range-based for loop. Yeah, I'm going to fold this one so that we can look. All right, so now I'm going to write another one, and it's going to be a little bit different. So this time I wrote it with this ampersand, which you may remember means pass by reference. So if you write a range base for loop with no ampersand, what you're actually pulling from the collection are copies. So each character C that I pull from that collection is actually a copy of it, a by value, if you will. If you put an ampersand in there, C++ is going to give you a direct reference to the original, which means that you can do stuff to it. So you can, for example, say, I want to overwrite each character with its lowercase form. And then we will print it out. At the end, and what you'll see is, and what you should do is experiment, take this away and see what happens. But because I intend to overwrite each character as I'm pulling it out of the collection, I use this ampersand, which gives me now the power to make alterations to the characters in place. So at the end, we'll see that the H and the E and the L are all now lowercase. So that is, it's just a really elegant way of manipulating the elements of a string collection in this case. Okay, so that's that. How are we on time? Sorry, I know I tend to go over, but I want to get a lot of content to you. So we're going to do the basics of vectors. It's going to look very, very similar. So I'm going to make a vector and I'm going to do something similar with it. So I'm going to move this stuff off to my notes. Okay, so now vectors. Vectors are also collections. Strings are specialized because they are collections of characters specifically. That's what they're built to do. Vectors are collections of whatever you want them to be. So you can make vectors of anything that you want them to be. And what I mean by that is you can make it a collection of any type of data that you want. You can make it a collection of strings, which is sort of a second layer on top of the string itself. So this is a collection of collections of characters, if you will. You can make collections of integers, which is what I'm going to use for this example. And then remember standard library collection, so it turns out that they have a lot of the same operations. So you can get the size of the vector, which is the number of elements in it. Now an empty vector, an empty string has something that's kind of printable and a nothing string. Empty vectors have nothing that's printable, but they do have a size. And the size is 0. So same for strings. I wish it would clear this. Can you clear this? Oh yeah, you can clear it. Okay. So size is 0, kind of like the string collection. So anyway, you have the size function. That's nice. You have the at function, although in this case there's no individual elements to get yet. So let's put some stuff in here. The way I typically do this is with the curly braces, and then we can put some numbers in here. So I'll put like -5, -3, -1, 0, 1, 3, 5. I'll just put some numbers in there. So let me run that and just show you. Now it has 7 elements in it, but you can use the same. It's the same stuff. This is why we're doing this lab with them together, is because they have very similar functionality. They also have the array style subscripting. I don't use that just because it's not my preferred way of typing it, but I don't care what you use. You use whichever you like better. But you'll notice we'll get the -5 here. Same thing. I'll leave that one as a breadcrumb, but I used the .at version for it. So you notice those are the same. The trick to using them is to remember when you're working with the string that it is a collection of characters specifically, whereas every vector you have to remind yourself what is that a collection of. So my vector, my vector v is a collection of integers. If I wanted a collection of something else, I can make that, which I will in just a second. Okay, so looping a vector, watch. I'll spread this out so it's more readable. Same loop. You can also, by the way, say v.at I. Since this is an integer from that collection, v has integers in it, I can do math on them, so I could like double them if I wanted. Which we'll print it out in the next loop. So you can use this kind of loop to see the position where things are at and print out that information, and you can also access them and do things like alter them. But notice it's the same loop as we used for string. Same loop. We also have range-based loops. So you grab one element of a collection. The collection in this case is my vector v. The elements, so now I have to just stop and think. Well, if the collection is v, what are the elements in v? They're integers. So they're integers. I'll call it, I don't like I, let's call it n. So for each integer n that I pull from the collection v, which is a collection of integers, I'm just going to print them. Using my range-based loop. Now what they should show is that they've all been doubled from the I equals 0 type of loop. So notice there's the first pass where they're the original values, and then the second pass where they've all been doubled because of what I did in the first loop. You also, with the vector, have grabbing the individual elements by reference, which would allow you to make alterations to them. So let's just say, I'll just count them down. So this is pretty powerful. There's a lot of information missing when you write code this way, like how did the integer get there and where did it come from? So it takes practice and thought. It came from v, which is a collection of integers. I'm calling it n because I have to have some way of referring to it if I'm to use it. And it is a reference back to the original integer from that collection, and that means that I can alter it. Now in the case of a vector, you can't just print out the whole vector, you sort of have to do the work, so I'm going to need this loop. Strings will just print themselves, the vectors won't. So I'm going to have to go back to this thing. Press run, yeah. And then notice the last pass. So there's the originals, then they get 2, 6, 10, then they get doubled, and then they all get decremented by 1. So the reason why we're doing these together is because the operations are very, very similar for strings and vectors. You have to stop and think about, if I have a string, I have a collection of what? I have a collection of characters. What can I do with characters? I can overwrite them with other characters. I can overwrite them with upper or lowercase forms of themselves if they are alphabetic characters. I can test them to see if they're digits or punctuation or anything like that if I want to. With strings. With vectors, you have to look at the vector and then ask yourself, what does this vector have in it? What are the individual elements of this particular vector? In this case, they are integers. So I have to think about that whenever I'm working with vector v. It's got integers, so what can I do with integers? Okay, so that's the basics, and then I'm going to bring up the lab and just do a quick orientation on a couple of the functions to get you started. Don't forget there's a supplemental video, and I suspect that this supplemental video has a full walkthrough of the lab, so just a heads up, it's like massive spoilers if you want to figure this stuff out for yourself. If you view the video in advance, then I just sort of, highly recommend, of course, that you don't just copy it, but you think about what you're doing. I use vectors a lot. I'm using them all over my ray tracer program as an example, all over the place. They're very popular data structure. Okay, so I'm going to switch over, I'm going to switch gears, I'm going to go grab some code and just get you started so that you sort of have the right frame of mind about things. Is this it? Yeah. So let me go grab the files. Okay, Baby Doll confirms that the supplemental video does have a walkthrough of the entire lab. So, okay, so I'm going to do like 5 minutes of very quickly just giving you some tips if you want to try it for yourself first. And then the supplemental video does walk through the entire lab, which is probably what a lot of you experienced in the spring. You sort of had a mad scramble after we all got sent home to just sort of get through the semester and try to be successful about it. So I'm going to grab the functions.h and .cpp here and put them into my REPL and then just show you a couple things inside of them. This is functions.h. Okay, so one thing about functions.h here, it is all headers, right? Function headers. So this one is not, other than putting your own name in here, there's no work to be done here. The programming work is in the CPP file. And then I'll grab the CPP file, which is just waiting for you to build functions inside of it. So all of the work, literally every last bit of code that you write for this lab should be in functions.cpp. You shouldn't have to touch, in fact you shouldn't touch the main lab file. You are going to need this word list, just so I don't confuse anybody. This is the data that the program is going to test itself against. So you do need wordlist.txt with all that stuff in it. Be careful how you spell wordlist.txt, by the way, because if you look at the testing file, it's expecting that that word list file be present and that it's spelled exactly that way. So make sure when you put it in your REPL that it's spelled exactly that way, or you will fail some of the tests. Okay, so I put it there and named it correctly, but then you don't touch it, because if you do change it, you're likely to fail some of the tests. It's a whole bunch of garbage, but it's there to see if your string and vector functions are working correctly. Okay, so let me just give you a couple of examples. Reading a file. So you already know how to do this, so I'm not going to do it all for you. But the reason why I'm asking you to do this on this project, on this lab, is because you need it for the remaining, like all 3 of the remaining projects use this stuff. So you know that you're going to have to ifstream to open, check if open, loop through the lines. You have to do that same stuff. You have to ifstream, and then you have to do an if is open, and then you need a while loop to read it. pseudocode. So in this while loop, oh, and you're going to need a, so this is the main reason I came in here, is because you're going to need a vector of strings. I'll just call it v. So the job of this function is to read every one of those lines and add them to a vector. And the way you add things to a vector is with the pushback function. You can also use this on strings to attach characters at the end. So that's the whole loop. You set up, you have this vector v, and then while you're reading lines from the file, you're going to push them onto your vector. And then when you get to the bottom of the function, you simply return the whole vector. So this function's job is to read in every line of a file, store every line of those files into this collection, this vector, and then return that vector. The reason why this is here is because the unit tests actually use that data from the file loaded into this vector to test your other functions. Okay, so that's the gist of this function. I just did an example of to uppering and to lowering. You're going to need some kind of a loop there. Okay, let's do digits. You kind of know how to do this already, but I'll do the digits one. So I like range loops for this, but it's a counter. So if you read the instructions, it says, return a count of all digits in the input. Well, I know how to do that now. I like range loops for this, so I'm going to pull each character from that input and test it. So if it's a digit, I need a counter, don't I? Yep. I'll separate that out so it's easier to read. So there's the digits. That's all it does, is it cycles through. I used a range loop because I like that, and I also used the value range loop because I don't need to change the string, I just need to detect digits in it. So I start a counter at 0, it's initialized. I loop the input string, that's the collection, grabbing individual characters and then testing them to see if they're digits. If they are, I increment the count, and then I return the count. That's it. That's the digits one. So here's, I'm going to scroll all the way down to this function right here, all digits. And then this should be it. So thanks for your patience. As usual, I can hear like dinner ramblings outside, I think, so I'm starting to get antsy myself. This should be it. Okay, so you also have functions in here that take vectors and do stuff with them. So if you look at the documentation for all digits, it says compute the total number of digits in all strings in a vector. So I have to cycle through this vector and do counts. So I'm going to need a counter. Initialize it to 0. I know ultimately I'm going to return it. And then I need to cycle through it. So I like range loops for this. The collection is V. And then I just have to remember, well, what am I getting as I cycle through V here? I get strings. Okay, well that's easy enough. So for each string S, as I pull it from the vector V, what do I want? I want to know how many digits are in that string to add them to my overall count. So count plus equals something. So this is the whole trick, and this is one of the things that I'm trying to teach you in the form of this lab. Sometimes you already have a function that does the job that you need. So, the job that I need is I need to know how many digits are in this string. Well, I have a function that takes a string and tells me how many digits, so I will just use it. Done. I take the S that I got from the vector, I pass it to my digits function, which will count the digits in that string, and then I will accumulate those onto my counter. So once this loop is done, every string has had its individual digits counted by that other function and then accumulated onto this counter, which I then return. So that's supposed to happen in this lab. You're supposed to realize, oh, all I really have to do is cycle this vector and then pass the string to some other function that I wrote that does a job. So that's a lot. I've been talking fast for a long time, so thanks for sticking it out if you stuck it out, which a bunch of you did, so that's awesome. Unfortunately, this is programming algorithms too, and we have a lot of content to cover, so do our best. From this point on, there's always at least one and often two supplemental videos, so if it felt hurried or if you just want some additional hearing me say it at some other time of the year, it's likely that I teach it slightly differently many times based on my audience, so you guys kind of hung back and let me go fast today, so thanks for that. I hope that's enough to get you started, but as Baby Doll has confirmed, the supplemental video has the full walkthrough, start to finish of the entire lab, so it's recommended that you try to do as much as you can on your own so that you learn it, but you do have the supplemental video as a backup if you need the extra help, where I go through and I solve the entire lab. It's probably another hour to an hour and a half of viewing time, but you know you're going to get the right answer if you do that. So that's it. Thanks for listening to all of that. Wishing you all a good week. I know that we're busy with the group project coming up. It's short, but not everywhere super simple, so you want to work together as a group to make it function. And the sooner that you can encounter any obstacles there and start swapping questions and answers, the better, so that you can complete it, feel successful, and move on to other things. Yeah, I think so Baby Doll's just saying in the chat that the supplemental video is like all spoiler. So just heads up about that. I put it there because I made the content and it's recent enough that it's still this same lab, mostly in this form, probably in this case exactly in this form. So anyway, keep that in mind. It's there as a backup. I mean, you view it when you think it's going to be the most beneficial to you. Okay, have a nice week. I will see you on Tuesday next week. Everybody take care. Use Piazza. You're surrounded by really good people who have been using that tool quite nicely. So please get out there and give people a chance to ask and answer questions. No, so the question in chat is, do you need to make the lab somehow different or unique? And you do not. You can just do it exactly as it's done if you want to, so that it works. If you want to, you can try different loop styles, but the only requirement in this case is that you pass the unit test. So do whatever it is that you need to do to pass the unit test. If you want to experiment with something a little bit different and you still pass the unit test, then that's perfectly fine. But it's also perfectly fine if you just do it exactly like I did it. I probably did it in the way that I consider to be the most direct and the most sort of clean and easy to read and understand. Okay, everybody be good. Do something that makes you feel good, that makes you feel happy, at least for a few moments in the week. It's probably easy to forget to do that sometimes, especially if you're working and doing school. Take a moment here and there. I'm going to get up in the morning and go for a walk myself. I guess it doesn't make me happy, but it clears the mind. Okay, thanks for sticking it out, and I'll see everybody on Tuesday next week.